Good evening, everyone. I am Sanjay Anand, studying third year BTech Triple E in Karunya University. Today, in our lab experiment, we are going to see arithmetic and logical operation using 8086 microprocessor.
The first experiment, first subtopic addition. So this is come under the arithmetic operation. Uh, Here we can see that this is the assembly code for addition of two numbers. So here I declare a variable ax and the initialize value of 1. Then I have declared another variable bx and I initialize the value as 4. So this is the keyword for uh, the instruction. This is the instruction for adding two numbers in 8086. So now let's compile and run. Here we can clearly see about that. Initially, the value of the A has been 1. Now it is changed to 5 by adding A and B. Now the value has been stored into the AX. So now the value has become 5. So same like that, we move on to subtraction. So this is the assembly code for subtraction. This is similar to the addition, where we will declaring A and B. Then initializing a value for A is 7, then B is 4. And this is the instruction for mm, subtracting the two numbers in 8086. Now we'll compile and run. So now the value of initially the value of A has been 7. Now it's changed to 3 by subtracting the two numbers. So now we move to the multiplication. So this is the assembly code for multiplication. So from the past to explain, we have seen that we have declared two variables like that we will be declaring. Then for multiplication, this is the instruction for multiplication of two numbers. Now we will compile, run. So we can see that by multiplying the two numbers of A and B, the value of 3 twos are 6. Now the value has become to 6. So now we go to the division. This is similar to the this is the same assembly code like multiplication. And now the instruction for this division is div. Now we'll compile and run. Now the value has become division 6 divided by 2 is 3. So we can clearly see that the AI value become as 3. So up to this, we have completed the arithmetic operation 8086. Now we move on to the logical operation 8086. So the first operation we are going to do is OR gate. So this is the assembly code for OR gate. Now the instruction for doing OR operation in the 8086 or we are ORing A or B. Now we will compile and run. So the binary value for 3 is 0, 1, 1 and binary value of B is 0, 1, 0. So by making the OR, the value will become 3. So we can clearly see about the value 3 has come here. So same like that, we move to AND gate. So this is the similar code for AND operation in the 8086. So the instruction for ANDing two numbers is AND. Will compile and run. So we can clearly see now the AND operation has been done. So now we'll move on to the off adder. So this is the assembly code for off adder. So here we are declaring three variables CX, DX, and BX. So the CX is for the CX, we declaring a CX and initializing value as 0, 1. Then now we are declaring a variable dx. Now with this move dx comma cx, what will actually do means the cx value will be assigned to the dx. Then move bx comma 0. Now we are initializing the bx value. Then and of cx comma bx. So we know that cx value is 0, 1 and bx value is also 1. Now which will and the two variables. Then the and is in half adder we'll be having two gates, one is AND gate and XOR gate. And AND gate will be and AND gate is used for carry, then XOR gate is used for sum. So by AND CX and BX, then after that, for some we'll for carry we'll doing AND of CX and BX, and for some we are doing DX XR of CX. So now we'll run and see. Now we can clearly see that by adding two numbers in half adders, the sum will become 0 and the carry will become 1. So the sum has become 0 in the D register, then the carry has become 0, 1 in the C register. So this is all about the arithmetic and logical operation using 8086 online emulator. Thank you for watching.